This video is on Unit 2, Chapter 4, Lesson number 2 on pure imaginary numbers. Your notes here for the imaginary numbers, the first bullet says equations such as x squared plus 1 is equal to 0 have no real solutions. So mathematicians defined the imaginary number to represent their solutions. The imaginary unit I is defined as I equals the square root of negative 1. This is useful when working with square roots of negative numbers. A pure imaginary number is written in the form bi, where b is the real number and I is the imaginary part. So let me explain what all that means. Up till this point, when you tried to take the square root of a negative number, your calculator either spit out some kind of an error message or like this one says, non-real answers. In Algebra 1, when you were trying to solve quadratic equations and the discriminant was negative, your teacher told you that there were no solutions. In Algebra 2, we are going to define those solutions in terms of the imaginary number system, the complex number system. So what we have to do is we have to go to mode in our calculators, and down here, several lines down, you're going to see the word real. And then right next to it says A plus BI. I'm going to hit enter and I'm going to turn on my imaginary numbers. My complex number system is now on. So real was all the real numbers, and we learned what real numbers were. The A plus BI includes all of the complex numbers now in the memory of the calculator. So look what happens now when I try to take the square root of negative 25. The calculator is going to tell me that my answer is 5i. So let me explain that. Your imaginary unit, and you need to know this, when we're taking the square root of any negative number, like negative 1, that automatically gives us an I. The square root of negative 1 is equal to I. As we get down in here to some of the examples, you're going to see what happens to give us something like that when I had the square root of negative 25, we can rewrite that as the square root of negative 1 times 25. So the negative 1, by definition, the square root of negative 1 is an I. And then we know that the square root of 25 is a whole 5. So that's where that 5i comes from. When we simplify negative square roots here in this next section of our notes, this is where I'm at. Step number 1 says rewrite the square root of negative a as the square root of negative 1 times a. Step number 2, break a down if it is not a perfect square. And then thirdly, simplify the radical, recalling that the square root of negative 1 is I. So let me explain. Number 1 says the square root of negative 9. So we're going to rewrite this as the square root of negative 1 times 9. Now, the square root of negative 1, again, by definition, is an I. And the square root of 9 is 3. To write that answer, you're going to use I kind of like a variable. It's not a variable. We know that I represents the square root of negative 1, but we don't ever put the number behind it. It's 3i, not I3. Number 2, square root of negative 196. Is the square root of negative 1 times the 196. And the square root of negative 1 is an I. And the square root of 196 is 14, I think. Square root 196. Yes, it's 14. So my answer here is 14i. Now, here's your shortcut. As soon as you see a negative underneath the radical, like on number 3, you can rewrite it with the I outside. Now, square root of 5, I can't do anything with that. That's actually my answer on number 3. So let me show you number 4. I've got the square root of negative 80. I'm going to go, because there's a negative underneath, I'm going to rewrite it with the I outside. Then we're going to try to simplify to 80. In lesson number 1, we reviewed how to reduce these radicals, and I showed you the little trick in the calculator. So I'm going to go back to my y equal and do 80 divided by x squared. Second graph. I'm already in the 0 points, so I'm going to arrow up to the first perfect number, which is a 5. So 4 radical 5. So this is 4i radical 5 for my answer on number 4. Number 5, I've got the square root of negative 32. Again, that negative that's under the radical is the square root of negative 1, which means I have an I outside. Deal with that first. Then the 32. 32 divided by the x squared. Go to your table of ordered pairs, and it's 4 radical 2. So my answer is 4i square root of 2. Number 6, square root of negative 192. Immediately, I'm going to take the I outside because that's what the negative under the radical means. I have an I outside because the square root of negative 1 is equal to I. 192 divided by x squared is 8 radical 3. So that's 8i radical 3. The only difference between 1 through 6 and 7, 8, 9, and 10 is 7, 8, 9, and 10 have coefficients. So you have to remember, like on number 7, I got to remember the 4. So it's going to be 4i times the square root of 36. Well, the square root of 36 is 6. And 4i times 6, just multiply the number parts, and you get 24i. Number 8. Again, the negative underneath is the square root of negative 1, so that's going to give me an I outside. I need to simplify the 18. Y equals 18 divided by x squared. Table. Arrow up, and it's 3 radical 2. So 5i times 3 radical 2 gives me 15i radical 2. Number 9, the negative underneath gives me an I outside, and I have 4i radical 7. Now 7 is prime. I know I'm done. Number 10, I have a negative 2 out front, and the negative that's underneath gives me an I to join the negative 2, and I have that 45 left under the radical. Y equals 45 divided by x squared. Go to the table, and 3 radical 5 gives me negative 6i radical 5. All right, I think you got the hang of that. The next two are identical. Moving on. Powers of I. So in this section, my goal is to try to make you understand that there is a pattern here. So if you look at I to the first power, it's equal to I. Because I is the square root of negative 1. I squared, when we square that square root of negative 1, we just get a negative 1. I to the third power is a negative I to the fourth power is a 1. Now you keep going. I to the fifth power is an I to the sixth power is a negative 1. I to the seventh power is a negative I to the eighth is positive 1. So what you should be noticing here is these match. Your powers of I repeat after 4 degrees. So, very quickly, we could do I to the 9th power equals I. I to the 10th power is equal to negative 1. I to the 11th power would be negative I, and I to the 12th power would be 1. And you're going to hear me say something silly like, I won. Negatives are in the middle. I1, negatives are in the middle. And that tells me the I to the first, I to the second, I to the third, and I to the fourth. Now, all of that is well and good. It's very difficult to remember. It's very difficult to apply to these problems. So what I'm going to say to you is the two that I really need for you to know and know well are the first two. I to the first power is I. It is equal to the square root of -1. I squared is equal to -1. The rest of this we can do in the calculator. Well, let me show you. Number 13 says I to the 15th power. Now, I is down at the very bottom of your calculator. I don't know if you can see it. It's the blue I above the decimal. So if I hit second in the decimal, I get the I. I'm going to use my exponent button and put in my 15th power. And my calculator tells me that that's equal to a -1, negative I. I to the 62nd power, second decimal is my I, raised to the 62nd power is -1. The issue comes in. I'm going to add another. If I have I to the 200, let's say 233. If it's some big giant number, your calculator, for some reason, adds a lot of extra. Now, here's what you need to take away from the notes here. I to any power is either I, -1, -I, or 1. So where in this answer that the calculator has spit out is my answer? Well, on this one, it's at the end. This 1.7e -12 is not the answer. The answer is I. What if I gave you I to the 230, let's try 32. Where's the answer in this? Again, keeping in mind that your answer should be either I, -1, -I, or a +1. So on this one, the 3.2e -12i is not your answer. The answer is 1. So if that exponent is rather large, you may have to interpret the answer. All right, down on products of pure imaginary numbers. Again, we can do this by hand or we can do it in the calculator. And I'm going to concentrate my efforts on the first four that you see here in the calculator. So I have 4i times 7i. 4i times 7i is -28. And it's because 4i times 7i is 28i squared. And again, I squared is equal to -1. This is one I need for you to know. So this becomes 28 times -1, which is a -28. Number 16, -4i times 2i times -9i. -4i times 2i times -9i is -72i. And again, by hand, the reason why it's -72i is if we do these one at a time, -4i times 2i is a -8i squared. -8i squared. I squared is -1. So -8 times -1 is a +8 times the -9i. 8 times -9 is -72, and then you've got your I. 17 and 18, again, in the calculator. On number 17, I have 2i cubed times 5i. 2i cubed times 5i is positive 40. By hand, 2i cubed, 2 cubed is 8, I cubed times 5i is 40i to the fourth. I to the fourth is a positive 1, so you have 40 times 1, which gives you the 40. But y'all, if you can put these in the graphing calculator, it's fine. On number 18, the only reason why we can do this one in the calculator is because this square is going to undo the square root. Otherwise, we're going to have to look at doing this by hand. I've got in the calculator for number 18, open up a parentheses, I times the square root of 3. I have to arrow to the side to close my parentheses, squared, times negative 8i is being squared. So parentheses, negative 8i squared. And the calculator's going to tell me 192. So there's the answer on that one. If you were doing this by hand, I squared, square root of 3 squared is just 3, because when you square root and then you square it, those two operations are opposites of each other and they cancel each other out. And then negative 8i squared, negative 8 times negative 8 is a positive 64. And then you got your I squared. From there, we would need to multiply the 3 times the 64 to get 192. I squared times I squared is I to the fourth. And I to the fourth is equal to a positive 1, which gives you the 192. All right. Again, if you do those in the calculator, I'm okay with that. 19 and 20 are a little more complicated because you cannot just stick these in the calculator. What we're going to do here is we have to simplify the i's first. You have to make sure you take out the i's first. So on number 19, I have I times the square root of 18 times I times the square root of 10. Then what we can do is multiply the outside parts. I times I is I squared. And multiply the inside parts. 18 times 10 is 180. Now, a little bit ago, I said, remember that I squared is equal to negative 1. So this is negative 1 times, we're going to simplify the square root of 180. The square root of 180 reduces to 6 square root of 5. And when you multiply negative 1 times 6, you get negative 6 times the square root of 5 for the answer there. The next one, again, we got to take out the I. It's wrong. It's not negative. So we have I times the square root of 24 times I times the square root of 3 times I times the square root of 2. And now we can multiply the outside parts. I times I is I cubed. And multiply the inside parts. 24 times 3 times 2 is 144. And I cubed is, if you think about, if you want to go back up and look, you can. I cubed is negative I. I cubed is negative I. You might have put it in the calculator. At this point, on this one, you actually could, because the square root of 144 is a perfect square. I cubed is negative I, and the square root of 144 is 12. So I have negative I times 12, or negative 12I for my answer. All right, those are your notes for Chapter 4, lesson number 2 on pure imaginary numbers. We will work on the assignment in class.